What if I told you there exists a mathematical problem so deep that it took about 300 years and ultimately a 19-year-old teenager proved that it has no solution? This is about the story someone who proved that the solution is impossible and the proof changed the mathematics forever. The hero of our story is Évariste Galois, a 19-year-old French teenager. In France, in that time, everybody was protesting against the government. He was also in that protest, and he came to the eye of government. And once he was called for a duel. Okay, and he knew that if I go for the duel, I will die. But he still go for the duel. He still fought. Ultimately, the day before of the duel, he wrote everything he know about his discovery. He wrote a letter to his elder brother and wrote everything he know. He wrote to his elder brother that don't need to cry for me. I have each courage to die at my 20s. Anyways, when he was discovered the theory, nobody was acknowledged him. And ultimately, after his after he shot dead in the duel, his thesis were lost. But after 14 years later, one of the mathematicians found them and he published them. But still, for another 40 years, everybody couldn't even understand the discovery of that guy. So, let us anyways, let's try to understand what algebra actually is and what was the question that was unsolved for about 300 years. Actually, the algebra is the study of polynomial equations and their roots. This journey started thousands of years ago. Actually, our ancient peoples, Babylonian and Egyptians, gave us the early polynomial problems. But the symmetric study of algebra was truly born in Islamic Golden Age, when the great mathematician Al-Khwarizmi wrote his legendary book Al-Kitab Al-Mukhtar fi Hisab Algebra. In fact, the algebra was comes directly from this book. Anyways, over centuries, mathematicians kept pushing further and further, and ultimately, one of Indian mathematicians we everybody know, the Sridhar Acharya, gave us the general solution of second-degree equations. Now, the natural question that comes to our mind that how polynomial equations actually come. I mean, how ancient peoples can generate a polynomial equation. So that we need to understand, and I will give you a very simple example. I mean, in those times, uh, field were there. So let's say one field, one field is, let's say, 10 square foot. Okay, one field is 10 square foot. The area of the field is 10 square foot. Okay, square foot, and one side of it is and the given that one side is 4 unit bigger the other. Okay, if then that's mean if this side is x, this side must be x plus 4. Then it is very much easy to construct the polynomial equation that this x into x plus 4 will be 10 and x square minus 4x minus 10 will be 0. Okay, so here we construct a polynomial equation. I definitely gave you a very simple example of a polynomial equation, but in this way, ancient people actually construct polynomial equations. This is a second degree, and sometimes they can construct a third degree equation. And by the time they realize that we need to solve it, because x is variable here, if we don't solve this polynomial equation, no, then the equation has no value for us. Okay, so that journey started from this. I mean, the finding of the root, the journey of algebra started from this. We have that urge to find the root of the polynomial equations. Anyways, I already told you that Indian mathematician Sridhar Acharya gave us the general solution of the second degree equation. But then Italian mathematicians Tartaglia and Cardano, okay, gave us the formula for third degree equation. And this is also there is also a fascinating story in between. So definitely I will try to tell the story maybe in another video. And then the Cardano students Ferrari gave the solution of the general solution of the fourth degree polynomial equation. Every single time a new degree was we can able to solve a new degree equation, the general question that comes to our mind that what about fifth degree equation? Then there will be a polynomial equation. There will be a general solution of a fifth degree equation. And this question, can you find a general formula for the fifth degree polynomial equation? This one question actually obsessed the greatest mathematicians about 3000 years, but all of them failed until Galois in 1832, a 19-year-old boy gave us the proof, gave us the theory that this 5 degree equation cannot be solved by only the coefficients. He don't answer the question. He invented an entirely new branch of mathematics. And actually what we call it, the group theory, the starting of the modern algebra. In this series of this is going to be a series of videos, and we are going to understand exactly how he thought, how his thought, not his thought process, but I will try to tell you how actually group theory evolved, how the concept of group theory came. And in this today's video, I already told you the history a little bit, and we'll try to give you some. And before going deep down in the background, I will try to give you some tools that we can use, that will be used in the next video to understand the background of group theory, how group theory came, how the concept of group came. Okay, so let's start. Let's say I have a polynomial equation x square minus 2 equal to 0. Then any mathematics student can easily tell us that the solution of the system will be plus minus root over of 2. Now if you are in q, that's mean if you are in rational numbers, then do you know root 2 and minus root 2? Because root 2 and minus root 2 are irrational numbers. You don't know the value of root 2 and minus root 2. So root 2 and minus root 2 does not belongs to q. Okay, so one question now, the thing that comes to our mind, that I am trying to solve an equation and the solution of the equation is not belongs to here. Let me give you some example that will be more clearer for you. Let's say x square plus 1 equal to 0, x square equal to minus 1, and x equal to plus minus iota, where I square equal to minus 1 or I equal to root over minus 1. Okay, this is not actually properly correct to writing I equal to root over minus 1. Anyways, I am writing it here for beginning. Anyways, now the thing is that in real number system, this iota has no position, because in the real line we know that 0 and it is going to till in minus infinity, and this is till infinity, and iota has no position in that real number system. So what we thought that okay, just try to put iota here anyway. And anyhow, let's try to extend it. Our thought process was maybe iota is not here, but we try to put it, we have to put it in our number system. So what we did that we just take the real line, this is x, this is the real line, and we draw just perpendicular to the real line, and we gave the name iota here. This is 0, this is 1, 2, okay, 2 iota, and so on. Okay, minus iota, then minus 2 iota, and so on. We gave the name of the, and after doing this we have the position of iota. Okay, now the thing is that we extend our system from R to complex number. Okay, For this example, what can we do? Because we are in rational numbers and our solution of the system is plus minus root 2, we know that. So this root 2 and minus root 2 is not belongs to Q. So what can we do that root 2 and minus root 2 belongs to Q? Okay. Then similarly we have to extend our extend our rational number. But before doing that, we know that x square minus 2 equal to 0. Okay, so we know the relation between the coefficients, okay, and the roots. So what is the relation? Let's say the root of the equations are r1 and r2. If r1 and r2 the roots of this equation, then the relation of the coefficients and the roots are r1 plus r2. We know that this is actually formula. We can directly have this will be minus b by a. That's mean that is b0. So that is going to be 0, and r1 r2 is going to be minus 2. Okay, now let's say I am writing the solution of this equation 1 in order pair. Let's say r1 comma r2, sorry, r1 comma r2. Okay, and let me name it as sigma 1. Now we are in rational numbers. Okay, we are in the field of rational number. Now if we flip, now let's say we take this r2 comma r1. Is there will be any effect in these equations? Then this equation will be r2 plus r1, and this is going to be 0, and this will be r2 r1, this is going to be minus 2. And even if I look at the roots of this equation, root 2 and minus root 2, okay, root 2 and minus root 2, then also the this will satisfy, because root 2 minus root 2 is 0, and root 2 into minus root 2 is minus 2. Even if we flip them, minus root 2 plus root 2 equal to 0, and minus root 2 into root 2 is minus 2. Okay, so flipping them is not the problem here, because we are in a rational number. We don't even know root 2 and minus root 2. Okay, so then if we flip them, there will be no problem. Okay, but now my question is that, let me give you an example. Let's say India, Pakistan and Afghanistan. Okay, or let's say A, B and C, team A, team B and team C. Okay, they have a war between them. Okay, now if team A has some members, team B has some members, team C has some member. Now each member of team A know them, but they don't know the members of team B and team C. Okay, if the member of team A, okay, if one member from team B and team C, okay, maybe I don't know from which team the member coming, maybe from team B, maybe from team C. Let's say from team B, one member try to attack the members of team A. Now can the members of team A understand this member? Let's say B1 is the member. If you want to attack team A, member of team A, the member of team A cannot identify the member is from team B or the team C. Okay, because everybody, it is clear that member of A cannot identify that the attacking member is from team B or team C. Both of them are identical for the members of A. The members of A only can identify the member of itself. Maybe from any other fourth team, let's say team D, any member is attacking, then even the members of A cannot identify that this is from which team is attacking to him. Okay, so this is the thing. Anyways, I think I able to give you the idea that if some element is not in Q, what does actually this mean? Okay, so the swapping up, and what I already told you, that sigma 1 and the sigma 2, the swapping up r1 and r2 and r2 r1 is allowed if I am in Q, because I don't know what root 2 and minus root 2 is. Okay, but now the one question come to our mind, that if we try to make our team bigger, if I want to make our domain bigger, that's mean I am in Q. Okay, I want to take root 2 and minus root 2 in myself. Okay, then what will happen then? Okay, how can I actually make it bigger? So I am not going in further details here. Okay, because this is a bit complex thing. If some beginner is watching this, it will be difficult how actually this is happening. This is actually a field. Okay, and a plus b root 2 are the elements of this field q root 2 equal to a plus b root 2, where a and b is coming from rational number. And you can see by the definition of this set, you can clearly see that q is a subset of q root 2, because 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 any element, let's say a is from q. Okay, then I can write a equal to, let's say x is from q. Then we can write x equal to, okay, x plus 0 into root 2. Okay, where a equal to x and b equal to 0. So therefore x belongs to q root 2. Okay, so definitely q is a subset of q root 2. And in q root 2, root 2 is also there and minus root 2 is also there. Because how minus root 2 is in q root 2? Because 0 into a plus 1 into root 2, where a equal to 0 and 1 equal to b. Okay, and this cut down this a. Okay, so this is also in q root 2. And similarly, if b equal to minus 1, minus root 2 is also in q root 2. Okay, so now look at this equation once more time. Okay, x equal to plus minus root 2, but the only difference here is that the last time we are in q, and this time we are in q root 2. Okay, that's mean this time the only difference is that this time we know root 2 and minus root 2, we can identify them. Okay, now if I write that r1, if r1 and r2 are the roots of this equation, this is equal to 0, and r1 r2 equal to minus 2. Okay, but this time sigma 1 equal to r1 comma r2. Okay, but if we swap them, r2 equal to r1, that's mean r1 equal to root 2 and r2 equal to minus root 2. So we know the value of r1 and r2. Now r1 is a box, let's say r2 is a box. We already put the root 2 value in r1 box and minus root 2 value in r2 box. So if we if we swap the values, if we swap the values, minus root 2 in r1 box and root 2 in r2 box, then this will an invalid idea, because we already assigned that in the very early step we already assigned that r1 equal to root 2, but now we are assigning that r1 equal to minus root 2. So this thing is totally invalid. So if I do this swapping up r2 r1, okay, this one is invalid because we already assigned that r1 is root 2 and r2 is minus root 2. Now we are assigning that r2 equal to minus root 2 and r1 equal to root 2. So this is completely baseless. Okay, so it is clear that in the field of q, okay, we had two symmetries. We had two permutations. One was in q, we had two permutations. One was sigma 1 and other was sigma 2. Okay, but here in q root 2 we only have one symmetry. This is sigma 1. Okay, so this is the difference. Now I think I able to tell, I think I am able to tell you actually how the extension is happening. Now taking bit difficult example. Okay, let's say we have this equation. Okay, and the solution of these equations are x equal to this omega. I think anyone read, I think that everybody can understand, and where omega cube equal to 1, and I'm not going to the detail how the roots come from it, but these are the actually these are the roots, and this. Now the question that comes to our mind, that in this case, if I am in, again, if I am in rational number, okay, if I am in rational number, I don't have any idea about the roots. These are totally identical. These roots are totally identical for me, because I don't know what these are. If, let's say, let us assign, if these roots are totally indistinguishable for me. Let's say the roots of this, if the roots of the equation are r1, r2, r3, and I am don't assigning which root is which. So if I do this, this is, I mean, if I do this, this is also valid. Okay, if I do this, r1, r3, r2, okay, this is also valid. If I do this, uh, r2, r1, r3, if I do this, r2, r3, r1, okay, if I do this, r3, r1, r2, okay, and r3, r2, all the permutations of the roots are identical, are valid for when I am in rational numbers, because the relation between the roots and the coefficients here is that r1, r2 plus r3 equal to 0. We know these results actually from 11 and 12. r2, r3 plus r1, r3 equal to 0. r1, r2, r3 equal to -2. Okay, these things, and for any permutation of these things are valid, because we don't know what these things are. Everything here is identical for me. So if I swapping them here and there is no problem in q, at least from q, because everybody of them is identical for me. Uh, they all convey the same message for me. Okay, so this everyone is identical for me. Now if I want to identify them from the previous example, how we adjoin root 2 in q, here similarly we can adjoin this in q, and the definition will be a plus b cube root of 2, where a b is coming from q. Okay, this is all. So this is the extension, this is the adjoining cube root of 3, 2 cube root of 2. Okay, and for this case, okay, if I extend it here, then I know cube root of 2, but we don't know this and this. So if I know this, then the r1 value is assigned as, let's say r1, we assigned the r1 box, we fulfill the r1 box with cube root of 2, then the value of r1 is already assigned. I can't change it anymore. Okay, if I am swapping it, then because I know this value, in my domain this value is here. If I now change the value of it, I can't do it. It is not possible for me to do it. Okay, so in this case I am swapping r1, r2. So for me r2 and r3 is unknown. In that case, for cube root of 2, for this case r1, r2 and r3 is unknown, but r1 is known. So if I am swapping them, this is not valid, because once I now I assigning r2 as cube root of 2, this is not possible, because I already assigned that r1 is cube root of 2. This is not possible. Okay, so this is an invalid permutation for this, for this field. Here also this is invalid. Here r1 is there, this is also invalid, this is also invalid. Okay, this is also invalid. And but here r1 is here, the value of r1 is cube root of 2. In that case r1, this one is valid. For this case, again r1 is here, just I swap up r3 and r2, this is also valid. So in this field, the only valid permutations are this and this. Okay, now can we construct again, so that this permutation, actually only this permutation is valid, for like just like the last example? Yes, if we again we actually adjoin this. If we again adjoin this, and the definition of this will be a plus b cube root of 2 plus c omega. Okay, where A, B, C is coming from Q. Now look at this. Omega is also here. Okay. Now for me, each and every value has. I mean, this also here. This value Q. This value is also in. This value is also in this. Okay. This value. This value is also in this. So each element, each root of the equation, each root of the equation we already know. Okay, so if we know each root of the equation, then we already assigned, we fill the R1 box with this. Now we are filling R2 box with this and R3 box with this. R3 box with this. Okay, sorry, my mistake. With confusion I am writing this. Okay, anyways, this is the thing. So now each and every root is known for us. Each box is filled. So everything is known for us. Nothing is, so they are not identical for me. They convey different message for me. Okay, so each and every permutation is, so this permutation is now invalid. The only permutation is valid for me is this. So again, we in the last example we saw that ultimately we come to a single element. Here also we come to a single element sigma 1. So ultimately we come here. Ultimately here also we come ultimately here. Okay, so this is the thing I want to tell you in this video. Okay, in the very next video I will going to tell you how actually group theory evolved. Okay, so these things are the background that I need to these are the prerequisites that I need for the upcoming video, and I think the next video will be more enjoyable. We can understand how group theory evolved, maybe not in the detailed manner, because the evolution of group theory actually coming from the Galois theory. If you study the Galois theory properly, then you can understand it. But Galois theory is much more advanced. Even I don't know about the Galois theory, but to know the core of group theory, if you have some knowledge about this, then you will have the interest to understand the group theory, actually why I am reading group theory, and everything. Okay, so knowing the history, knowing the evolution is very much important to build the interest about the subject. So thank you everybody. Please subscribe, like and share. Thank you.